Right, question 2. Prove by induction. So first of all, prove by induction, we use the case where if it's true for n is 1, so let's prove it's true for n is 1. So we're going to get 2 to the power of 3 times 1, which is 3 plus 1 is 4, plus 3 times by 5 to the power of 3. So that's going to be 2 to the power of 4, 16, plus 3 times 125, which is 375. Added together, I'll give you 390, 20, 91. And then 17 into 391, we'll go 17. Goes in there twice to make 34, remainder 5, and 3 times. So there you go. 391 is divisible by 17. It goes in 23 times, so it's true for n equals 1. Okay, then you assume it's true for n equals k. So that means we're allowed to use 2 to the power of 3k plus 1 plus 3 times 5 to the power of 2k plus 1. That's f of k. And then you try and show it's true for f of k plus 1. Or that's f of k, sorry. F of k plus 1. So we're going to replace k plus 1 in there. So it's 2 to the power of 3 times k plus 1 plus 1 plus 3 times 5 to the power of 2 k plus 1 plus 1. Okay, we simplify. That gives us 2 to the power of 3k. 3 times 1 is 3, add the 1 makes 4. And finally, simplify this. 5 to the power of 2k plus 2 plus 1 is plus 3, so it's 5 to the power of 2k plus 3. Now, if it's a divisibility question, you try and find the difference between consecutive terms, and if you can prove that is divisible by 17, and you know that the original one was, then every single term is. So we're going to do the difference between consecutive terms, so f of k plus 1 minus f of k. Let me move this down a bit. Okay, so f of k plus 1 was this one, so it's all of that minus all of that. Now you'll notice that it's got 3k plus 4 and 2k plus 3, but if we can get one of the originals being part of the this question here, if we can get it into the form of 3k plus 1 and 2k plus 1, we know that's divisible by 17 because we've assumed it is originally. So I'm going to try and get these powers into the same form as these powers here. So let's go down a little bit. So I'm going to rewrite this one as, rather than 3k plus 4, I wanted to say 3k plus 1 because that's what it was originally. So I'm going to take 2 cubed out as a factor. So that means 8 times 2 to the 3k plus 1 now. That's the same as that. And this, I want this to be 2k plus 1. Check. Oops, sorry, too far. Yeah, I want it to be 2k plus 1, so I want to get the powers to be 2k plus 1, so we'll leave the 3 there. And I will also then take out k plus 1. Now, because it wants to be 2k plus 1, I'll take out a factor of 2. So I'm going to get 5 squared. So that will be 25 times 5 to the power of 2k plus 1. Then I will simplify that by making it 75. And we'll go for here. So f of k plus 1 was this. So it's 8 times 2 to the power of 3k plus 1 minus 75, sorry, plus 75 times 5 to the power of 2k plus 1. That's f of k plus 1. Now we're going to take away f of k, so we're taking away the original, which is 2 to the power of 3k plus 1 minus, because we're taking away both of them, 3 times 5 to the power of 2k plus 1. Now we can simplify our powers here, because you've got 8 times 3k plus 1 there, and you're taking away a 2 to the power of 3k plus 1, So therefore that is going to take one more away. So you had 8 of them, you're taking away one of them, so you're left with 7 times 2 to the 3k plus 1. And then the second one, if we group these two together, at the moment we've got 75 and we've got a minus 3, so that makes 72 times 5 to the power of 2k plus 1. So now all the powers are dealt with. We need to think about how we can get the original form, and the original form had a 3 in it. It was there, so we want there to be a 3 in front of the 5 to the power of. So if I go down, we want there to be a 3 here, so I'm going to leave this the same, and I'm going to rewrite this as something times 3, so it's 24 times by 3 times 5 to the power of 2k plus 1. Okay, now we've got a 7 here and a 24 here. If we can get the same number in front of both of these, then we can factorise that out. So if I split the 24 into 7 and 17, which is going to be useful later, I could rewrite it as 7 times 2 to the power of 3k plus 1 plus 7 times 3 to the power of 3 times 5 to the power of 2k plus 1, and then plus 17 times 3 times 5 to the 2k plus 1. Now we could factorise out the 7 out of this, 2 to the 3k plus 1 plus 3 times 5 to the 2k plus 1, and like that, and plus 17 times this amount here. Now we don't really care what this amount is because there's a 17 in front of it, which means this here, this whole term, must be a multiple of 17. This one here we already assumed was a multiple of 17 from before, so the fact it gets times by 7 still means this is a multiple of 17. So we've proved it's true for n, we've shown it's true for n is 1, we've assumed it's true for n is k, we've found the difference between the terms using k plus 1, and it is still a multiple of 7. Hence we've done it.